financial aid, maybe loans, to help you deal with the costs of university. Oh, thanks so much. Actually, this one's not mine. But yeah. Thanks a ton, Tina. Appreciate it. Now, in the States, tuitions are, in case you aren't familiar with it, they're much higher yet. Tuitions for undergraduate universities not infrequently run $40,000 to $60,000 a year, and it is very common for a student to be building up debt all throughout the university time to the tune of perhaps $40,000 a year. Sometimes 35, sometimes 45. And when you build up debt, what happens? What besides the debt being added to every year by the new tuition that you need to pay also starts to happen? You borrow money from a bank. How do they make money? Interest. Yeah, they charge interest. So let's draw a causal loop diagram involving these components. Thank you again, Tina. So if we wanted to link up on the one hand your bank account balance, so let's just call it for simplicity debt level. Okay, debt level. So this might be you have I'll just call it debt for simplicity. You have a debt of $100,000. You have $120,000. Be glad it's not, right? And then we have interest. How would those be linked up? Anyone?
Well, debt accrues interest, and interest adds the debt.
Okay, so debt accrues interest. There's a positive link there, right? And interest to debt, is that positive or negative?
It's positive.
Positive indeed. So the more debt you owe, the more interest accrues, and the more debt you owe, right? Now, let's think about one of these people who owes this staggering level of debt. So high that it threatens to be as big an issue as the housing crisis in the US. If students default at large-scale levels on their debts, it could shake the financial system as much as the housing crisis in 2008. But let's suppose there's a student who owes this debt and then goes and gets a job after university and starts to work, maybe as a software developer. And they're earning, let's say $40,000 a year, and they have some costs associated with housing, associated with food, associated with a lot of the basics, transportation. But they have some amount of money to put down for the debt on an ongoing basis. Maybe they have, if they're lucky, $20,000 out of the $40,000. They can put down. More likely to be $10,000. Now, what happens to the debt when they get that job and that income starts coming in? Does the debt vanish instantly? No. So what's going to happen? Suppose their income is their amount of income that they can invest is above the level of interest that is being accrued. What's going to happen to the debt over time? It'll decrease. But will it decrease, so this is salary component for investment, or, for putting away into the bank for repayment, I guess I should say. Not so much investment, it's for repayment. So the debt doesn't disappear. It has to be paid down, right? There's a relationship here between interest and debt and salary for repayment and debt, which is of a special sort. If we increase the salary available for repayment, it's not that the debt immediately disappears. We could double the amount of salary. They go, and they get an $80,000 a year job the next year. That doesn't instantly halve the debt. They can pay down the debt sooner, but it doesn't instantly halve it, right? Double their amount that they can invest, but it doesn't instantly halve the debt. Similarly, interest is going to lead to an increase in debt, but it doesn't immediately multiply the debt by huge factors. It accrues over time. It builds up. It accumulates ladies and gentlemen. It accumulates. So there's a special type of relationship here between some of these variables and other ones. Debt is kind of an accumulation, you might say, and interest that's being increasingly owed, and salary are not accumulations. They're kind of flows into that accumulation. Okay, so we could say debt is kind of this bathtub, and interest is the level of the water in the bathtub is the amount of debt you owe, and interest is water coming into the bathtub, and this salary of repayment, and so it's the rate of water coming in is the amount of as the speed with which interest is accruing, and salary for repayment, that's the speed of water going out, that's repaying it, lowering that debt level. How do your salary that you have for repayment, maybe it's $20,000 a year, is exactly equal to the interest that's being generated on a per year basis. What will happen to the debt? It'll stay the same. It'll stay in balance. It's like the amount of water, the rate at which water is coming in equals the rate at which it's coming out. It'll stay the same. If the salary for repayment, the amount of salary you can put away is less than the interest, what happens? That's going to be just increasing. Slower for sure than it would if you had no salary to invest, but it's going to be increasing. Ladies and gentlemen, what we're talking about here is the types of relationships between variables, the semantics, the meaning of this length, for example, how interest relates to debt. That's a special sort of thing. And just because we have this length from interest to debt with a plus on it, it doesn't communicate, it doesn't capture the fact that it's an accumulation relationship. That as we double interest, it doesn't double debt immediately. In fact, it takes time for the debt to build up. Same with salary. If you double the salary amount available for repayment, it doesn't immediately have the debt. It slowly decreases it over time. It's a special sort of relationship associated with these arrows. Yes, they're labeled plus and minus, but it doesn't really communicate the fact that one's an accumulation and the other two are sort of flows into that accumulation. And ladies and gentlemen, that, no less, is the focus of our lecture for today. And we're going to start to look into, at a practical level, at an interactive level, at a hands-on level, how we can capture these concepts within the context of modeling. Okay? Great. So ladies and gentlemen, I'd like you to go and call up your AnyLogics if you haven't already. We're going to dive into them here in just a moment. Meanwhile, what I'm going to do is I'm going to show just a few slides to orient us, and then we're going to see how they apply to this particular case of an AnyLogic model. Okay? So what we're going to be talking about now is moving on from this issue of model mapping with system dynamics to this issue of model formulation. Okay? So we were talking about causal loop diagrams as kind of a semi-quantitative depiction. Remember, with causal loop diagrams, we could reason some about the behavior of the system. So without salary to repay it, for example, the interaction between debt and interest would lead to what behavior over time? Anyone remember? Okay, if you come out of school and you owe $80,000, a horrible thought, but a reality for many. What sort of behavior will be elicited over time here? Yeah, okay. Does it go up with a straight line?
No, it goes up exponentially.
It goes up faster and faster, because the higher it is, the faster at which the interest will be accruing, right? The more you owe, the more interest you owe per year, and it's going to rise up. So it's actually going to rise up exponentially. I didn't do a very good job drawing an exponential curve there, but it's something like that. And at a numeric level, it looks something like that, e to the alpha t, okay, where this is reflecting sort of continuous accruing of the interest. Okay, so we can get some insights out of a model like this in terms of the possible behaviors, but really to proceed to a fully quantitative understanding, to be able to ask what-if questions that yield quantitative outcomes, we need to go beyond that. We need to put in place a fully precise, unambiguous specification of the model. And this includes picking some values for parameters, specifying the relationships between different variables, including between accumulations and the flows into them, and talking about very specific rules that apply in the model and the initial conditions for the model. Okay? So the model formulation elaborates on the problem mapping. You can take a causal loop diagram and grab the whole or pieces, very commonly, and turn it into a quantitative model. It's not that. This is useless. In fact, you use this for brainstorming about what might go into the full model. And you'll often carve out pieces of it to start with, okay? Small pieces. That causal loop diagram is not fully quantitative. I can't run that. It doesn't say in what way exactly does that depend on interest. There's a plus here. It indicates the polarity, but it doesn't say the exact relationship. And we're going to put in place some mechanisms from system dynamics which allow us to explore this. And I had talked about this before, and I'm going to cut to the chase with the two key mechanisms of system dynamics. Ladies and gentlemen, system dynamics has a very small vocabulary associated with it, okay? It has a few building blocks that we use in creative ways to do really interesting things. The power lies in the combination of just a few elements. And that small modeling vocabulary basically consists of two fundamental elements. Stocks, these are the accumulations. They represent the state of the system. And flows. And flows are the rates of change. They represent the rates of change of the stock, the differentials. They represent kind of the verbs of the system, where the stocks represent the nouns, in a way. Okay, current state, and the verbs are where the action's at. The verbs are what's changing that state, the flows. Okay, the flows. And we're going to be analyzing systems in terms of stocks and flows, and it's going to lead to a characterization of a system organized by state, where the flows depend on the values of stocks. So let's talk about stocks and flows, and we are going to build some. So have those AnyLogics ready. Within minutes, we're going to be diving into them. So stocks represent accumulations. They collectively represent, if we consider all the stocks for a model, represents the current state of things, the current state of the system, current situation of the system is totally summarized by the stocks. Those are they represent the current situation, okay? And in general, we can measure them at one instant in time. I see that clipping is going on in a most unseemly fashion, so pardon me while I engage in frobbing behavior, okay? So here we